All right. So yes, your ability to understand the data will be either greatly enhanced or limited by your knowledge of that subject. So again, if you're familiar with baseball data, you will understand certain things, and you will know like this number is, you see a on base plus slugging of like 1.1, you go, oh, that's great, right? And if you see a number like 5, you go, oh, that's impossible, okay? Whereas if you're not familiar with baseball at all, what I just said is just gibberish, okay? What's OPS, right? That kind of stuff just doesn't even, make sense. And so, towards the end, well, I want you to just start thinking in the back of your mind about the final project. And the final project, I'm going to have you guys pick a data set that is interesting to you. And I want you to pick a data set where you have familiarity with the subject, okay? Because again, if you're not familiar with baseball data, don't pick baseball data to analyze because you're not going to be able to understand it, right? And there's a lot of kind of like popular data sets out there. And like one of the most popular, like a very popular one is this like wine tasting data set. And it's an interesting data set, but it's interesting only if you're interested in wine. And if you're not familiar with wine, and I don't know, I can't imagine any of you being like super into wine right now, okay? It's like a middle-aged person thing. And maybe I shouldn't say that because you can certainly become a sommelier or whatever at any age. Well, over 21, I guess, legally. But yeah, if you can't tell me the difference between a Merlot or a Cabernet, then like, probably not the best data set to analyze, okay? And so anyway, I wanted to just kind of start off before we really even get into data analysis and whatnot, just do a little bit of a demonstration here. And so you can follow along if you want. Oh, and okay, all right, so let me just talk a little bit. Let me go back to these PDFs of these tutorials that are here in place of the data camp stuff that, again, I apologize. I don't know, I can't get a hold of them to activate my subscriptions and stuff. But anyway, as far as, I have like little bits of code and then, their output. And so you'll see things like, okay, if you want to assign the variable 42 to X, this is what you type in. And, one thing you'll note, or maybe I haven't even written this, but when you store the value 42 into X, like nothing gets output. You just hit enter and it, like nothing reacts. And it feels a little bit strange because you feel like every time I type something, like the computer should react in some way. But when you store a number into a variable, the computer doesn't react. It does it, but it doesn't do anything. But if you want to say like, okay, what was that value of X that I stored? Then you type in X and it says, oh yeah, X is 42 and things like that. So I recommend, and as silly as it is, just to kind of like type these things out yourself. Now, don't just copy and paste it, okay? Because if you copy and paste it, you miss out on the typing. And there's merit to the typing because there's just certain like annoying things, like it's case sensitive. If you capitalize one thing or if you spell something off just by one letter, it's not going to work. And so it forces you to, it trains your eyes and your brain to start recognizing, some of the deviations or just these little details. This is something I noticed, and I guess it's just a skill or something that develops as you have to code, is that your ability to pay attention to character by character things is something that kind of develops as you type out more code. And this is just, it's kind of like muscle memory and kind of like, certain things like, my partner, she does nothing with code. And so when people write out certain sentences and certain words, like, and I don't know if this is necessarily indicative of the fact that I write a lot of code and she doesn't, but just like certain words are like just interchangeable, right? Like if you have like the word big and huge, like in her brain, they're kind of just like interchangeable, and like she might not notice the like certain things. Whereas like I notice like just like character by character, I don't know, certain things I just kind of notice. And I think this is something that just kind of develops by the fact that when you type out code a lot, you realize like this character by character difference is really, really important, okay? And it's not really important in anywhere else in life. That's the issue, is that if you're not doing any kind of code, like paying attention to individual characters is not super, super critical, okay? But it is important here. And so I recommend just kind of trying to develop that little aspect of skill in your life of just by typing out the code yourself rather than copying and pasting, because when you copy and paste, you lose out on that, okay? And so anyway, these are just some basic PDFs that get you through some introductory stuff in R, and I just recommend that you just type these things out yourself just to kind of replicate the results here. Okay, but anyway, let's work through this in-class demo that I have. This is an RMD file, an R Markdown file, and I'm going to go ahead and download it, and we will open it up in RStudio. And this is just a very basic kind of exploration, exploratory analysis of some basic data here, okay? When you when you open it up, you might get some kind of thing that says you need to install the tidyverse, or you need to install Gapminder, okay? And you can run the command install.packages tidyverse, okay? Now you don't need to do this every single time. If you don't have it installed, you have to type this in. This is install.packages tidyverse, okay? And what I like to think of, the analogy I like to use for package is in R is, think of it as like a cookbook, okay? A cookbook with recipes in it. And if you want to, I don't know, create a certain recipe, okay? You need to you need to like have the cookbook, but you only need to purchase the cookbook once, right? You go to the store, you purchase it, okay, and then you own it. And then anytime you want to use a recipe, then you have to pull the recipe book or the cookbook off your bookshelf and open it to that page, okay? You can think of the installation as the purchase of the cookbook, okay? So you only need to do that once, okay? There's no sense in reinstalling the package. So here I'm gonna use the tidyverse package. I only need to purchase this cookbook once, okay? I'm gonna just run it here just to show you. It's already installed, and so I'm getting this warning that it's like, this is already installed. You know, do you wanna do it again? So you purchase this, you purchase the cookbook once, you install it once, and then anytime you want to use it, you have to pull it off your bookshelf. And that is done by calling library, okay? So you call library tidyverse, and this is kind of like, let's go to my library and open up this cookbook, okay? And I do that by typing in library tidyverse, and that's gonna load up the library, okay? And here, some messages pop up sometimes when you load up a library, sometimes it doesn't. When you are working in R, you can just click this little play button in the right-hand corner here, and it says run the current chunk of code. I don't know. Okay. And that will load up the library there, okay? There is another library, okay, called Gapminder, and again, in order to use the stuff here, you have to kind of, quote, purchase the cookbook or install the package one time. You don't have to do it every single time. But then in order to use, say, the data or whatever's in there, you have to load it up. So here I'm going to load this library by running library gapminder. So that's a package that has some data in it. And then I'm going to load the data in the gapminder data set by calling data gapminder. You can run lines of code in a code chunk one line at a time by holding down Control or Command Enter. On a Mac, it's Command Enter, I think, or Control Enter. On PC, so I'm going to hold down Control Enter, and you will see when I hit that, it sends it down into the console. And then I hit Control Enter again, and it's going to run data gapminder. And when I do that, in the Environment tab, this is things that are loaded on my computer, and the gapminder data set has been loaded here. Okay. One thing we can do is we can take a look at the gapminder data, and I can do this just by typing in capital V view the data set, and that's going to load up kind of like a spreadsheet. Okay. And so this feels a little bit like Excel, except you cannot edit the data here. Okay, this is just a viewer, and it has information where it says here's the country, it's on this continent, this is the year, the life expectancy, the population, and the GDP per capita. These are just different things, and so we can kind of scroll, and we have so Cambodia in 1952, the life expectancy was 39.417 years. There was a population of 4,693,000, and the GDP per capita was 368. And then, as the years have gone by, the most recent numbers are from 2007. So in Cambodia in 2007, the life expectancy is 59.7 with a population 14,131,858, GDP per capita 1,713. Okay, we can scroll down to say, I think the United States somewhere in here. Okay, United States. Okay, so in 1952, the life expectancy was 68.44. Population of 157,553,000, GDP per capita of 13,990. And then in the year 2007, the life expectancy is 78.242, with a population of 301,139,947, and a GDP per capita of 42,951. Okay, and so these are just kind of some of the numbers in our data set, and you can kind of, again, this is something I encourage you is just whenever you have a data set, if you're kind of familiar with it, you should look up rows that you are familiar with to kind of make sure those numbers align with your understanding and expectation, to just kind of say, like, does this data make sense, right? Does it make sense that in the United States in the year 2000, this was our life expectancy or population and GDP? That seems to align with my knowledge and expectations, so that kind of makes sense. I'm much less familiar with what life was like in 1952, especially in, foreign countries, like Uruguay. If you told me the life expectancy was 66, I'd go, okay, I guess. I have no idea, right? But we have this information, and that's what we have. So this is just something you click view, and you do that. And there are a few kind of important notes. Oh, I keep forgetting. Let me, I got to pull up view quiz stuff. A lot of the data here is kind of interpolated and like best guesses. And there are, our countries have changed over time. For example, the country, Bosnia and Herzegovina was part of Yugoslavia until 1995. However, if you look at this data, it goes back, it just says Bosnia and Herzegovina, 2007. Bosnia and Herzegovina did not exist in 1952, okay? But it just kind of extrapolates and kind of says, imagine if the countries that we have today, if we rolled back the clock and things like that, what kind of numbers would we have, right? Germany was divided into East and West Germany from 1945 until 1990, and I think here it's just Germany, right? And so a lot of this kind of stuff is not like wholly accurate, and so just to kind of to kind of keep things, I guess, in a way that we can analyze it easier, it just says, all right, here's the country. These were the countries in 2007, and let's pretend we traveled back in time. And some of these numbers, these are a little bit too precise. Okay, like this was the population of, in Canada was exactly 584 people, and we're not going to know that. Okay, so just keep that in mind here. Okay. All right, let's create a basic plot, and let's just say, hey, we want to do a comparison between GDP per capita and life expectancy. And what we might expect is that when you have higher income and like when a country has a little bit more wealth and income, they tend to have higher life expectancy because, generally you'll have better infrastructure, more access to things like clean water and healthcare and just food. And so in general, you have kind of higher life expectancy. A big driver of countries with low life expectancy is infant mortality. And in countries where, you have less wealth and less income, infant mortality. And it was actually a major problem in the 1950s and 60s across the world. Infant mortality was quite high, and so life expectancy was low. And so we might just want to do a comparison and just see, is there a relationship between GDP per capita, which is a loose way of measuring wealth and economic activity, with life expectancy. And so we'll do this by calling ggplot, and we'll look at the data, and we're going to do an aesthetic mapping. We're going to take GDP per capita, that variable, put it on the x-axis, life expectancy, put it on the y-axis, and we will add points. And I can run this by clicking this little play button here. And when I do this, it creates a plot, okay? Now this plot there's too many dots. It's difficult to kind of make sense of, just because there's so many dots that all of these dots kind of get plotted on top of each other, and it's hard to really kind of make sense of it. So one thing we can do is we could say, here we're just plotting. There's 1,704 entries, and I can't see it. So we might say, let's just filter to one particular year, right? And so you can do this in the view. You can click filter, and you have this little thing pops up, and you can say, all right, let's for the year, let's just do, say, 2007 to, I guess there's no 2010, but I can just say 2007 to 2007. And so this filters our data just down to those entries, and we have 142 entries, and we can create a plot there. And correspondingly, to do that in our code, okay, we take our data set, and this thing is known as the pipe, okay, percent greater than percent. You can also do a vertical bar greater than. This is also a pipe, okay? And basically it just means take the result of the previous line and do this operation. So we start off with the Gapminder data set, and here I'm going to do an operation, and this says filter, and I just want where years is equal to 2007. One thing you have to do is you have to use double equals. Double equals means test to make sure that it is equal to 2007. Single equals is used to assign values, okay? So double equals says I only want the rows where the year is equal to 2007. We're going to take that result because Gapminder, after applying the filter, is basically this with 142 rows. Then what we want to do is we want to create a plot, and then we're going to plot those points. And so this plot will basically be the same plot as before, but just filtered down to the year 2007. Okay, so this was like everybody, and here we're going to just filter down to the year 2007. Okay, now let me give you your first view quiz answer for week 2 Monday is the letter D. D as in dog. D as in dog. Okay. And so we see overall there is kind of there is a trend that in general, as GDP per capita trends goes higher, life expectancy also tends to increase. Now we see kind of this L shape, and we see there's very kind of the life expectancy goes up dramatically from just kind of going from 0 to say 5,000-ish, and then once you're at around 10,000 and above, your the life expectancy of the countries goes up, but only kind of slightly. And one issue is that here we're using what's called a linear scale, where every kind of inch I move to the right, our GDP per capita goes up by around 10,000. But where you have things that are 50,000 is 10 times 5,000, right? And when you have kind of multiplicative factors, things are on different orders of magnitude, it might make sense to use a different scale. Oh, another thing is perhaps we can color our dots by some of the different continents, right? So in our Gapminder data, we have Asia and Europe and Africa, and we have these different things, and we can color the dots using the continents. And so here, I'm going to take the same thing. We're going to filter it down to just 2007. X goes on, GDP per capita goes on the x-axis, life expectancy on the y-axis. But now I'm going to color the dots based on continent. So I'll go ahead and I'll run that. And we can see we have the different kind of continents represented here, right? And we can kind of see these trends here. Okay, and so regarding the scaling, again, we can change some of these things to a different scale. So instead of a linear scale, we can have a logarithmic scale. Okay. Now, all of these things, where I'm just kind of typing in these things, geom point, and here, how would you know this is going to be scale x log 10? Okay. These things, you just you use the internet to search, right? And so you can always kind of go and you can say ggplot how to scale x-axis log, okay? And AI, the AI result says you can do scale x log 10, and you're going to find different things. And honestly, ChatGPT for finding some of these which functions and stuff is also a powerful resource as far as looking up things. Okay, now I want you to balance, okay, the use of say AI tools and ChatGPT and things like that with your own kind of learning. If you have an over-reliance on that, you're not going to learn these things yourself. But as far as like looking up and finding like, okay, what is the function I need to use? I think it's a great resource, okay, because it's going to be able to find and identify those things. But then you want to, once you find out what is the function you use, you want to type that out yourself, and you want to kind of incorporate that into your own learning and understanding here. Okay, so this is going to apply a log scale to our data. And this is, again, we are just exploring relationships. And now we see a little bit more of something a little bit closer to a linear trend. And here we can see, every kind of inch I move to the right, we're multiplying by approximately 3, okay? And you can see we're going from 300 to 1,000, so we're multiplying by 3.3. And then if I move, and you might even be able to notice the difference between here and here is just ever so slightly bigger than the difference from here to here. And we're multiplying by 3, multiplying by 3.3, multiplying by 3, and so on and so forth, okay? And so we could see kind of in general, nations where you have GDP per capita being higher, the life expectancy tends also to be a little bit higher. And in nations where GDP per capita is lower, life expectancy also tends to be lower. Although it doesn't fully explain all of that, there's still quite a bit of scatter within our data here. Okay. With our data set, okay, there are even more variables. Okay. One of the variables is population, all right, of how many people live in that nation. And so you could take the view and you can click this thing and it will sort by population. And so we have some nations with fairly small populations. Iceland only has around 300,000 residents, whereas China and India have over 1 billion. And this is from 2007. India has surpassed China as the most populous nation. But yeah, we have all of these different things here. Okay, so we can plot. We could change the size of our points based on the population here, and so I can map that variable pop to the size of the point. All right, and so this is again just exploring some of the relationships, and so we can see some of these things. And so these dots would correspond, the biggest kind of circles would correspond to China and India here. And we can see, we have smaller dots for some of our different nations and things of that sort here. Okay, and that's what we have. Okay, I don't know if I'm doing this too quickly or whatnot. We're just kind of, again, all of these things, I just have these kind of different things. And one thing I encourage you is, so you can download the RMD file and you can kind of, I think, click the little play buttons and stuff. You can also try just changing some of these things around. Like what happens if you swap life expectancy and GDP per capita? And how does that change the way the graph looks? How does, what if you change some of these things? And some of these changes will make sense and some of them will look funny. Just kind of take an exploration here, okay? Here we've been filtering all of our data based on just the year 2007. And what I can do is I can say, well, what if we wanted to compare what our graph looks like from, say, across different points in time. So here I can say, let's look at 1957, 1967. Let's kind of look at every decade. And on top of that, I'm going to use what's called a facet wrap. And what a facet wrap will do is it's basically going to create the same plot. So this is the plot for 2007. It's going to create the same plot for 1997, 1987, and so on and so forth. But it will put them on separate, what we call facets. So it'll create this plot for 1957, the exact same plot for 1967, the exact same plot for 1977. And that is accomplished by using facet wrap, okay? So, so let me kind of run this. And so we see, this is kind of a lot of data, and it's hard to see, but we can see, all right, this is what things looked like in 1957. Here's what it looks like in 1967. And what we see overall is like along the x-axis, we have GDP per capita. And so we see, if you compare like 1957 to 2007, overall, the wealth of the entire kind of world has shifted a little bit towards the right. And also the life expectancy has shifted up, right? So we have kind of the highest value at around 70 something, and now the highest value is 80 something, and the lowest value is 30 something, and the lowest value over here is a little bit better at 40 something. Okay, so we see kind of just comparing 1957 to 2007, we see kind of a shift of some of our data values. Okay, this is interesting. There in 1957, there was one nation with a very high GDP per capita. I don't know what that one was. I'm curious. I'm going to filter. Let's look at 1957, and let's sort GDP per capita. Okay, Kuwait in 1957 had a GDP per capita of 113,000. Okay, so life expectancy 58. So very kind of high wealth and income. I think in the 1950s, Kuwait, very oil-rich country, and so perhaps the per capita is perhaps not reflective of what was actually going on. Is that generally, even if like one person in the nation has like billions of dollars of wealth, when you take the average, it kind of just increases the per capita number. But that seems to be what's reflected there. Okay, but anyway, this is what we call a facet wrap, where we're pretty much creating the exact same graph, but just across different what we call facets. And here the facet is based on years. So we have the same graph for 1957 and 1967, and it's the same idea of what if I filtered just to that particular year or that particular setting, and it creates the same plot for those different points in time. Another kind of graph that I can create, and this is the last one I've put in this demo here, is what if we wanted to just look at a few different countries, a few different nations. I picked United States, China, India, Japan, and Canada just arbitrarily, and here I'm going to just kind of plot GDP per capita and life expectancy. We'll color it by the different country, and then I'm also going to add the population for the size, and then I'm going to connect these things using geom_path. Okay, so this is kind of a lot. I'm not expecting everybody to understand every single line just yet, but again, as I'm just kind of throwing this out there and exposing you to it, and as you start creating your own graphs and you see some of the same kind of lines again and again, you will gain familiarity with them. And so again, just kind of an exploration here, we can see, so in 1957, or I think 1952, Japan's GDP per capita was around 3,000, life expectancy of 60 something, and over time there's GDP per capita rapidly increased, okay, going from 3,000 to 10,000 to 30,000, and life expectancy also has greatly increased from around 60 to 80 something. Okay, we see similar things with Canada and the United States. The GDP per capita of Canada is less to the left of the United States, but the life expectancy in Canada tends to be higher than that of the United States. Okay, we see China has undergone some major improvements in life expectancy as well as GDP per capita. Okay, and similarly, India has also gone through major improvements in life expectancy as well as GDP per capita, with kind of starting, here. I don't know what number this is. Well below 1,000 to increasing quite a bit over here. So these are just, again, some exploratory graphics to explore some of the relationships that we have in our data. And this is just an example of how we can go about taking a look and using some of our visual analysis tools like ggplot to kind of take a look at what relationships might exist. And so this is a little bit just of a demonstration. Again, I encourage you to work through this file, retype some of the things, pay attention to when you use the pipe versus when you use the plus sign. Don't worry if everything does or does not make sense at this moment in time. You can always kind of pair some of these things, and you can take some of this and again, balance your usage of ChatGPT. Don't just ask it for all of the answers, but you can say, all right, here's a graph that was created. Can you explain line by line what each of these lines are doing? All right. And it's actually very good at kind of providing explanations like that. So, you don't want it to do all of its thinking for you. You don't want to just say, hey, make this graph for me. But I think it is a good resource as far as help me to understand what these lines of code are doing, okay? So, again, it's kind of like going to the gym and having a personal trainer. You can have a personal trainer that tells you this is how you should be doing your exercises, but then you do the exercises yourself versus going to the gym and asking the personal trainer, hey, can you lift the weights for me, right? And so AI tools, they exist, and I don't want to pretend like they don't exist, okay? They are there, and I think we just have to use them judiciously and wisely. That can help us enhance our learning here. All right, let me give you your final view quiz answer. I gave you 2, right? No, I only give you 1. Okay, then I will give you your last 2. Your last 2 are E as in elephant, second one is E, and the third one is C, C as in cat. So we have E as in elephant, C as in cat, and that should be all 3 of your view quiz answers. And we'll...
Sorry, I'm teaching in this room like 10 minutes from now.
Yes, and my class ends at 10:50, right? So
10:45.
No, 10:50. Yeah. Okay. So we will end here, and we will see you on Wednesday.